Let's take a look at some integrals. All these integrals fit into the standard integrals shown here. We will see how we can evaluate these integrals. We will first find the solution of the integral of the functions of the type 1 upon square root of x square minus a square. We evaluate this integral by using the method of substitution. Let us substitute x is equal to a secant theta. This implies that dx is equal to a secant theta tan theta d theta. Now, substituting the values of x and dx in the integral, we get the integral as shown. Using the identity secant square theta minus tan square theta is equal to 1, secant square theta minus 1 in the denominator can be represented as tan square theta. So the integrand further reduces to a secant theta tan theta whole divided by a tan theta. Now cancelling the common terms from the numerator and the denominator of the integrand, we get secant theta. On integrating, we get the solution as log secant theta plus tan theta plus p. Here p is the integral constant. As x is equal to a secant theta is equal to x upon a. Now, tan theta is equal to square root of secant square theta minus 1. On substituting the value of secant theta, we get tan theta is equal to square root of x square minus a square upon a. Next, we substitute the values of secant theta and tan theta in the solution. On rearranging the expression further, we get log of x plus square root of x square minus a square minus log a plus p. The sum of minus log a and p is a constant. So this sum can be represented as c. Hence, integral of 1 upon square root of x square minus a square is equal to log x plus square root of x square minus a square plus the constant. Now, let's use this identity to evaluate the integral of 1 upon square root of 4x square minus 36 dx. In order to bring the integral into standard form, we have to make the coefficient of x square equal to 1. So multiplying and dividing the denominator with the coefficient of x square, we get 1 upon 2 into integral of 1 upon square root of x square minus 3 square dx. Now the integral is in the standard form. Here a is equal to 3. Using the formula, the integral is equal to 1 upon 2 into log x plus square root of x square minus 9 plus the constant c. In addition to the integral of the type just discussed, there are some integrals in which the integrand can be expressed as 1 upon square root of a square minus x square. To find the solution of this standard integral, we substitute x as a sine theta. On differentiating, we get dx is equal to a cos theta d theta. Substituting these values in the standard integral, we get the expression as shown. The denominator can be rearranged by taking a square common among the terms. Using the identity sine square theta plus cos square theta is equal to 1, we can replace 1 minus sine square theta with cos square theta. This gives the integrand as a cos theta divided by a cos theta. cancelling the common factor from the numerator and the denominator. We get integral of d theta. On integrating, we get theta plus c. Now x is equal to a sine theta. This implies that theta is equal to sine inverse of x upon a. Therefore, integral of 1 upon square root of a square minus x square dx is equal to sine inverse of x upon a plus the constant c. Now, let's see how to apply this standard integral to solve the integral of 1 upon square root of 36 minus 4 x square dx. To bring this integral into standard form, we make the coefficient of x square as minus 1. So we multiply and divide the denominator of the integrand by the coefficient of x square as shown here. On simplifying, this integral can further be written as 1 upon 2 into integral of 1 upon square root of 9 minus x square. Writing 9 as 3 square, we see that the integrand is now in standard form. Comparing with the standard form, we can observe that a is equal to 3. Using the formula, the solution of the integral is 1 upon 2 sine inverse of x upon 3 plus the constant c. Further, we will discuss some integrals in which the integrand can be expressed as 1 upon square root of x square plus a square. To find such integrals, we substitute x is equal to a tan theta. This implies that dx is equal to a into secant square theta d theta. Substituting the values of x and dx in the integral, we get the expression as shown. Now, the denominator can be rearranged by taking a square common among the terms. By using the identity secant square theta minus tan square theta is equal to 1, the denominator can be represented as square root of a square secant square theta. On cancelling the common factors, we get the integrand as secant theta. The integral of secant theta d theta is log of secant theta plus tan theta plus the constant p. Now, we find the values of secant theta and tan theta in terms of x as shown, and then substitute them in the expression. Finally, rearranging the expression, we get log of x plus square root of x square plus a square minus log of mod a plus p. Since log mod a plus p is a constant, we have the integral of 1 upon square root of x square plus a square dx is equal to log of x plus square root of x square plus a square plus the constant c, where c is equal to minus log of a plus p. Now, let's learn to apply this standard integral identity to solve the integral of 1 upon square root of 4x square plus 36 dx. First, we bring this integral into standard form. For this, we multiply and divide each term in the denominator with the coefficient of x square. On simplifying, the denominator can be written as square root of x square plus 3 square. Now, the integral is in standard form. Using the formula, the solution of the integral is equal to 1 upon 2 log x plus square root of x square plus 9 plus c